is also related to something called the halting problem. This was originally done on Turing machines, which are a mathematical model of a general computer. You can do it in a Java program too. And the question the halting problem asks is, can you write a program T that will analyze another program T prime and tell you whether T prime ever halts? Does it ever stop executing? Or does it just run forever? And it sounds like a challenging problem, but you should be able to do this, you would think. But in fact, it's impossible. And why is it impossible to write this program T? Well, suppose you come to me and you say, here's my program T, and it solves the halting problem. Okay, I can make a slight modification to that. I can say, okay, if T tells me that T prime halts, print out, it halts, and then enter an infinite loop. And if it decides that it doesn't halt, tell me it doesn't halt, and then T itself executes a halt statement. And there's no reason you can't make these modifications. But now if you ask T to analyze itself, you've got a contradiction. Because if it decides that T is going to halt, the next thing it's going to do is enter an infinite loop, and it's not going to halt. And if it decides it doesn't halt, the next thing it does is execute a halt statement. In either case, it's wrong. And it's the same thing with the I am lying paradox. You're rigging the game by taking the fact that the system is supposed to do something, and then at the last minute you twist it so it does the wrong thing. Okay, what's going wrong here with the halting problem or with the lying problem? Because I've actually tried writing a program like this when I first heard about it. I started trying to do something that would analyze a set of input programs and tell you whether it would halt or not. But you need to analyze, in the case of Java, you need to analyze the bytecode in order to see what it's going to do. So you need to emulate a virtual machine on which you can run the bytecode and analyze it and see what it's doing. But when you run T on itself, you find that the emulated JVM is going to end up having to emulate another JVM because that's what the program T does. And so you get this, again, this never-ending descent of one thing emulating another, and just going on and on. You never come back from it. So what you have is this sort of, self-contemplating other kind of system. And what you really want is introspection. You want to somehow be able to analyze yourself, not simply make a model of yourself and study it from outside. You want to somehow actually look in on yourself. And this is one of the original ideas that was being kicked around when first cell matrix architecture was dreamed up. Now, if you look at software languages, you can see something like, for example, x equals 12. That's a string of 4 characters, x and equal sign and 2 digits. And you can feed that to various functions in the list. You can measure the length of that string is 4. You can pull off characters from one side. You can add characters to it. But if you feed it to a function called eval, something very weird happens. After you execute this, the value of x changes. And now x is equal to 12. And so you can look at the string x equals sign 1, 2 and say, is this data or is it code? And again, you can't tell just by looking at this. The only way you know if it's data or code is by looking at the stuff around it, by looking at how it's interpreted. Is it sent to a function that measures its length, or is it sent to eval? Okay, so 1986, Morley Raju, his friend over here, asked me a question. Have you ever written a program that prints out its own source code? It was a standard computer science question, but he just heard it. I've never heard it before. And if you think about it, it seems like it should be straightforward to do, right? So every program starts with 10 print, or 1986. Every program starts with 10 print. And what do you want to print out? Well, you want to print out your source code. So you print out 10 space print. And now you've copied your source code up to about here. And now you need to print out a double quote followed by 10 print. So you have to print out 2 of these to escape them with 10 print. And you can keep doing this and you're never going to finish, right? Because you're always sort of chasing yourself and you're not catching up. So how do you get a program to print out its own source code? Well, I was a graduate student at the time, so I had a lot of free time, and eventually came up with a C code that would do this. And this is basically just an initialization of an array of characters, and this is the actual main program. And when you run this, this is what it produces, exact copy of itself. And the main thing to know is that this side and this side look very, very similar. There's 2 differences, though. One, every string over here is surrounded by a pair of double quotes, which you need because you want this to be a string that can be read and acted on. But the other thing is, there's all these extra backslashes that you don't find over here. And backslash in C, it tells you the following character is just a character. Don't actually execute it. And that's basically what's happening is you're looking at this character up here. You don't know if that's code or data. You don't know if that's a backslash that's escaping the letter N, or if it's just another character. If there's a backslash before it, it's just a piece of data. It's just a character. And if there's not, like over here, then it actually means print out a new line. And so the insertion of this dual way of interpreting something as code or data seemed to be the key to making this program work. And that backslash eventually turned into the C inputs and outputs of the cells.